Bismillahirrahmanirrahim. I am Dr. Farooq Ahmad from College of Science, Mathematics Department, Majmaah University, Kingdom of Saudi Arabia. This is the lecture series about linear algebra, mathematics 229, 241 and 242. Today we are going to record lecture number 7, and our topic is how to find eigenvalues for a matrix of 2 by 2. This 2 by 2 matrix is very easy to solve, so we are going for the easiness first of all by 2 by 2, and then in the next series we will solve 3 by 3 matrices for this one. This is lecture number 7, and references book already mentioned in our previous lectures, the same lectures for the same references for the same series. This one is the matrix, that is 1 2 4 3, and for this matrix we are going to find the eigenvalue of this matrix. What is an eigenvalue? Eigenvalue is a real number, like this one. If this matrix is multiplied by this vector and there is a real number multiplied by this vector v for non-zero values of v, if and only if det of lambda ai, the identity matrix of the same order of this A minus the matrix A, is equal to 0. If the determinant of this matrix is 0, then the value of lambda is called the eigenvalues for this matrix, and we are going to calculate this by the very easy method by writing AV is equal to lambda V, and we can write it as lambda AI minus A, and we have to find det of this one. If this det is 0, then we will find the value of lambda. Lambda is an eigenvalue. This is a very simple definition of this one. Lambda is an eigenvalue of A, this matrix, if and only if det of lambda A into identity of the same order of matrix A, and it should be very clear the matrix A must be square matrix, because the det of only can be calculated for the square matrix only. The matrix is 1 2 4 3, and we can write it as lambda ai lambda is eigenvalue of A if determinant of lambda into identity matrix, and identity matrix have the same order of the matrix A, and because the A is of order 2 by 2, so the identity must be of order 2 by 2, and that is 1 0 and 0 1, and these two matrices are going to be added or subtracted and then multiplied by the first one is multiplied by the lambda. So when we multiply identity matrix with lambda, this results, this is a lambda 0 0 lambda minus 1 2 4 3, and we can subtract these matrices from each other to make one matrix, and we have to find also det of this matrix. This matrix will become lambda minus 1 0 minus 2, this is minus 2, and 0 minus 4, this is minus 4, and lambda minus 3, this is lambda minus 3, and this is the determinant, new determinant, and we have to find the value of this determinant, and that must be equal to 0 to find the eigenvalues. So we have to find the det. How we have to find the determinant? We have a very simple way we have already discussed in the previous lectures, multiplying the diagonal elements to each other and minus the reverse diagonal elements. So this lambda minus 1 is the first element of the first diagonal, second element of the first diagonal. This is lambda minus 3 minus the first element of the reverse diagonal, that is minus 2 into minus 4. This is 8. Directly we are going to calculate this one because it is very clear. This is minus 8, and lambda minus 1 into lambda minus 3, and this must be equal to 0 to find the values of lambda. We are now going to multiply lambda minus 1 and lambda minus 3, and from this that we can calculate. Now multiply lambda minus 1 into lambda minus 3. This is lambda square minus 3 lambda minus lambda and plus 3 minus 8 is equal to 0. This is lambda square minus 4 lambda and minus 5. And this is a very simple quadratic equation, and we can calculate by quadratic formula or by the factorization or completing the square, which is very easy for you. You can calculate the value from here, and the characteristic equation of this quadratic equation is 1 minus 4 and 5. To find the factor of this one, we can multiply coefficient of lambda square with the last constant, and factorizing the middle, and now we can check this one. Lambda minus 5 into lambda plus 1 is the same equation. When we multiply this each other, we have lambda square minus 4 lambda plus 5, and this is the multiplication of two linear factors. So the first factor is equal to 0 and the second factor is equal to 0. Lambda minus 5 is 0 and lambda plus 1 is equal to 0. This will give us lambda is equal to 5 and lambda is equal to minus 1. And this is the values of, these are the values of lambda, and so we can say that there are two eigenvalues for this matrix A, and we can write this matrix A into V is equal to lambda into V. The same result will be given. This is called eigenvalues of a matrix, and this is the our last lecture for the series of the matrices and determinant. And in the next series we will inshallah discuss about the vector spaces, and we will also discuss the vector spaces about the matrices and all other vectors in the next series. That series will also consist of 7 to 8 lectures. Thank you very much to join us in this series of lectures about linear algebra, mathematics 229, 241 and 242. And this is the end of these lecture series for matrices and determinant, but not end of the series of the linear algebra, because we are going to find more lectures for the vector spaces, and this will become another series. Soon we will see you in the series. Thank you very much. Welcome to Majmaah, Kingdom of Saudi Arabia.